Okay, let's dive into this. Every single day, you, me, all of humanity, we face this one fundamental, totally inescapable problem. Scarcity. We have practically unlimited wants, but painfully limited resources. So how on earth do we actually map out our options? Welcome to this explainer. Today we're going to unpack the ultimate blueprint of human choice and economic possibility. Let's get into it.
Here is how we're going to tackle this today. First, the blueprint of choice. Second, mapping the trade-off. Third, the math of sacrifice. Fourth, changing the boundaries. And finally, systems of decision.
All right, Section 1, the blueprint of choice, setting the rules of the game.
Before we can really navigate scarcity, we absolutely need a map. Enter the Production Possibility Curve, or the PPC. You might also hear it called the Production Possibility Frontier, or the Transformation Curve in some textbooks. But honestly, just think of it as our primary blueprint. It's basically a graph showing the possible combinations of two goods an economy can realistically produce, given the resources and tech it currently has. It literally draws a boundary line between what is achievable for society and what is scientifically impossible.
But for this blueprint to actually work, we've got to set up a controlled environment, basically the rules of the game. We operate under 4 core assumptions here. First, maximum efficiency, meaning every single resource is fully utilized. No one is just sitting idle. Second, binary output. Just for clarity's sake, we assume the economy only produces exactly 2 goods. Third, fixed capacity. The total amount of our resources is locked in, though we can swap them back and forth between uses. And fourth, static technology. The level of tech remains absolutely constant during our analysis. But hey, pay very close attention to that crucial caveat at the bottom. Resources are not equally efficient everywhere. Transferring them from one industry to another actually decreases productivity. You can't just flip a switch and turn a sterile microchip factory into a functioning wheat farm overnight without massive friction. Keep that in mind because it's going to be incredibly important in just a few minutes.
Moving right along to Section 2, mapping the trade-off, the guns versus butter anchor. To bring all this abstract theory down to earth into a very concrete scenario, we're going to use the most famous economic anchor of them all, guns versus butter. Up on the vertical y-axis, we have guns, representing maximum national security and defense. Down on the horizontal x-axis, we have butter, representing maximum civilian provision, consumer comfort, things like that. Look up at point A. 15 guns, 0 butter. That is total militarization. Now look down at point F. 0 guns, 5 units of butter. Total civilian provision. But let's be real, nations rarely live at the absolute extremes, right? Points B through E represent the spectrum of compromise. Moving along that curve shows us exactly how much of one good we literally have to give up to get just a little bit more of the other.
And this brings us directly to what we can call the operations matrix. Take a look at the 3 distinct zones here. Zone 1, which includes points A through D right there on that gold curve, is the absolute sweet spot. It is both attainable and efficient. We are squeezing optimum utilization out of our resources. Now look at Zone 2, point E, sitting inside the curve. Sure, it's attainable, but it's incredibly inefficient. Think of it like a massive factory leaving half its machines turned completely off. If an economy lands here, resources are sitting idle, underutilized, or just poorly managed. You could literally have more guns and more butter without sacrificing anything, simply by organizing better. And then there's Zone 3.
Zone 3 is represented by point F, way out there in the red area. I really want to hammer home the harsh reality of scarcity here. Any point outside the curve is fundamentally impossible with our current reality. It is an unattainable dream. You literally cannot reach it with your current productive capacity, no matter how much you might want to.
All right, Section 3, the math of sacrifice, understanding the physics of the curve.
So, let's look under the hood at the actual mathematics driving these boundaries. The very first physical property of our curve is its downward slope from left to right. The logic behind this is just an inescapable law of fixed resources. Because our resources are fully utilized, there's a strict inverse relationship. It works exactly like a seesaw. Producing more of one good can only be achieved by actively taking resources away from the other. To gain a unit of butter, you have no choice but to surrender a specific amount of guns.
To actually calculate this, economists use 2 specific metrics that are super easy to mix up, but absolutely vital to keep separate. First up is the MRT, the marginal rate of transformation. Think of this as the ratio of the trade-off. It's simply the units sacrificed divided by the units gained. But then we have the MOC, the marginal opportunity cost. This one zeroes in on the absolute sacrifice. It tells us the exact literal number of units that must be surrendered to gain exactly one additional unit of another commodity.
And this brilliantly illustrates our second property, the concave shape of the curve. Notice how it bows outward? Just look at the visual proof right there. To gain a constant +1 unit of butter, over and over, the economy has to sacrifice increasingly larger amounts of guns. First you give up 1 gun, then 2, then 3, then 4. This right here is the core mechanism of increasing marginal opportunity cost. And the why brings us all the way back to that caveat from the beginning. Resources are highly specialized. As you aggressively transfer resources from a task they are absolutely great at, like making guns, to a task they are terrible at, like making butter, you destroy productivity. You end up having to transfer more and more resources over just to get that same single unit of butter.
Now sure, there are theoretical exceptions to this. You could have a perfectly straight line if the MRT is constant, meaning every single resource is magically equally efficient at making both goods, or you could even have a convex curve if the MRT is somehow decreasing. But let's look at reality here. Because of resource specialization, MRT almost always increases in the real world. That means the standard curve you're going to deal with is always concave.
Next up, Section 4, Changing the Boundaries, Dynamic Frontiers.
The good news is, these economic boundaries aren't permanently locked in forever. Changes in capacity cause the boundary to move, and we need a mental diagnostic tool to understand exactly how. There are two distinct types of movement we look at: shifts and rotations. A shift impacts both commodities, creating a parallel movement of the entire curve. This is usually caused by something huge, like widespread economic growth or a massive natural disaster. A rotation, however, impacts only one commodity. It pivots outward or inward from a fixed access point, and that's usually driven by a sector-specific technological breakthrough. Let's visualize what this actually looks like.
Here we see macro capacity shifts. Over on the left, a rightward shift. Imagine a massive advancement in power generation that suddenly makes all manufacturing significantly cheaper. The result? We are capable of producing more of everything. The entire curve pushes outward. Now on the right, a leftward shift. This is what happens during technological degradation or resource destruction, like a devastating earthquake. Total production capacity shrinks across the board, physically pulling the entire curve inward.
Now contrast that with rotations, which are totally sector-specific. Look at the left side, a rotation on the x-axis. Imagine a revolutionary new agricultural tractor is invented. Our maximum gun output at point A stays exactly the same, but the maximum butter output swings wide open from point B to point C. On the right, it's reversed. A rotation on the y-axis means a tech upgrade specifically for guns. The maximum butter output is entirely unchanged, but maximum gun output rockets upward.
And finally, Section 5, Systems of Decision, the human element.
Up until now, we've really just been looking at the math. But out of all those possible, highly efficient points sitting perfectly on the curve, who actually chooses the exact coordinates? How does an entire society decide exactly where it's going to land?
Well, the answer is dictated by the dominant economic system. Generally, we look at two main models here. First is the centrally planned economy, where the government owns the resources and makes all the big decisions. Here, allocation is determined by central priority, and the primary motive is usually focused on overall social welfare. Alternatively, there is the market economy. In this system, private economic agents exchange freely with minimal government intervention. The exact coordinates on the curve are determined by the natural forces of supply and demand, and the primary motive driving those choices is profit. Basically, your system determines your society's priorities.
So the crucial point is this. When we look at the architecture of choice, we see that the math perfectly outlines our limits. It plainly shows us efficiency, sacrifice, and the harsh reality of scarcity. But the math itself is entirely neutral. It literally requires the human element to actually pull the trigger.
I want to leave you with this final, essential thought to take away from this explainer. The curve maps what is possible. It does not tell us what is desirable. We can map out exactly what it costs to trade butter for guns or civilian infrastructure for military might. But out of all the efficient possibilities on that curve, the real question is, what values will drive the choices your society ultimately makes? Thank you so much for joining me to explore the blueprint of choice. Keep questioning the data, and I'll see you in the next explainer.